Vectors are a mathematical concept that appears a little everywhere in physics. Velocity, displacement, acceleration, forces, magnetic flux density, gravitational field strength, electrical field strength, area, momentum. So many physics parameters are vectors. So it is essential to get a good grasp of what vectors are and how to manipulate them. In the first video about vectors, we learned that a vector is a quantity that contains both a magnitude and a direction. For example, the force on a boat. It has both a magnitude and a direction. We also realized that a vector could be described uniquely in space by two different systems of coordinates. Polar coordinates describe a vector with its magnitude and direction in reference to one axis. So you have the magnitude, which is the length of the vector, and you have the direction, which is described by the angle in reference to the axis. Vectors can also be described by Cartesian coordinates in reference to two perpendicular axes. X represents how much the vector extends in the horizontal direction, and y how much it extends in the vertical direction. This implies that the coordinates of a vector are not linked to the origin point or any point, as you can see in the graphic. In the previous video, we learned how to convert from polar coordinates to Cartesian coordinates. This means finding the horizontal and vertical components of the vector from its magnitude and its angle in reference to an axis. We also learned how to calculate the magnitude and orientation of the vector from its horizontal and vertical components. This corresponds to converting Cartesian coordinates into polar coordinates. In this video, we will learn something really important in physics: how to add vectors to one another. We will learn how to do this graphically and also algebraically. We have a vector A and a vector B. We want to find out what the vector A plus B looks like. So for that, let's draw vector A again, then from the tip of vector A, draw vector B. The vector A plus B will start on the tail of vector A and end at the tip of vector B. You know that displacement is a vector, right? Well, you can visualize a man walking along A, then along B, and the total change of position he will have experienced is the one described by the vector A plus B. What about subtracting vector B from vector A? This means finding a vector A minus B. To be truthful, nobody knows how to do that. But what we know is that you can add vector A to a vector minus B. So let's draw vector A, and from the tip of vector A, let's draw vector minus B. Vector minus B has the same magnitude and orientation as vector plus B, but in the opposite direction. So the vector A minus B will start on the tail of vector A and end at the tip of vector minus B. To illustrate this, let's do a quick exercise. We have three vectors, x, y, and z. Which of vector A, B, C, or D corresponds to x plus y minus z? Pause the video and figure it out. First, let's draw vector x. Then from the tip of vector x, let's start vector y. The next operation is a subtraction. So let's add minus z, starting from the tip of y. Now, the vector joining the tail of x and the tip of minus z will be the